Very good morning, students. In today's class we are going to solve problems based on the properties of DFT. So this is a problem which is related to symmetry property. The first 5 points of a 8-point DFT of a real valued sequence are 0.25, 0.5 minus j 0.5, 0, 0.5 minus j 0.86 and 0. Find the remaining 3 points. This is the problem statement they are given. So you need to identify which property to be used. So we have a hint here, that is the first 5 points are given. You have to find the remaining points, and also the points are related to a real valued sequence. Already we have discussed for symmetry property, if the sequence is a real, then you can make use of the symmetry property. So you have to identify the property which is the symmetry property to be used here to find the remaining 3 points. And also while doing the symmetry property, I have told you the main application of this symmetry property is if half of the values are given, the remaining half values you can calculate using this symmetry property, isn't it? So the solution is, first write what is the property you are going to use. So using symmetry property, and you have to write the statement also. So using symmetry property, the statement is x of k is equal to x conjugate of n minus k. So what is given is, the first 5 points are given, that is x of 0, x of 1, x of 2, x of 3 and x of 4 are given. So you have to find the remaining in the sense it is x of 5, x of 6 and x of 7. So how to find x of 5 is, use the symmetry statement, x of 5 is equal to x conjugate of n minus k. N is equal to 8, since it is a 8-point DFT, put n is equal to 8 and the current value of k is 5 here. So 8 minus 5, it is 3. So x conjugate of 3. So what is x of 3 given? It is 0.5 minus j 0.86. Take conjugate of that, will be getting us 0.5 plus j 0.86. So this is x of 5. In the same way you can calculate for x of 6 and x of 7. So x of 6 is equal to x conjugate of n minus k, n is equal to 8 and put k is equal to 6. So it is x conjugate of 2. So what is x of 2 value? From the given data it is 0. So 0 conjugate is 0 only. So therefore x of 6 is 0. And the last point, x of 7, which is equal to x conjugate of 8 minus 7, which is equal to x conjugate of 1. So what is x of 1 given? 0.5 minus j 0.5. Take conjugate of this, will be getting us 0.5 plus j 0.5. So therefore the remaining points are 0.5 minus plus j 0.86, 0, 0.5 plus j 0.5. So this is how to calculate the remaining values, provided the first half of the values are given, as well as these are the DFT of a real valued sequence. Then only you can apply this symmetry property, you can calculate. Hope you understood. Let us move on to the next problem. So second problem statement is, a 498-point DFT x of k of a real valued sequence x of n has the following DFT samples as: capital X of 0 is equal to 2, x of 11 is 7 plus j 3.1, x of k1 is minus 2.2 minus j 1.5 and x of 112 is 3 minus j 0.7, x of k2 is minus 4.7 plus j 1.9. So few values of x of k are given, and they are given remaining DFT values are to be assumed to be 0. So in a 498-point DFT, only we are having the values which is listed here, remaining values are 0. So you need to calculate the value of k1, k2, k3 and k4. So as I told, the property to be used is symmetry. How it is since it is given for a real valued sequence. You can observe in the first line the DFT of a real valued sequence x of n. So you can make use of the symmetry property. So what the property states is x of k is equal to x conjugate of n minus k. So what is n? N is given as 498, right? You have to calculate k1, k2, k3 and k4. So let us write what is given. X of k1 is given as minus 2.2 minus j 1.5. So x of k1 will be equal to x conjugate of n minus k as per the symmetry property. So put n is equal to 498, right? And if you observe the value of this x of k1, if you take conjugate, it is minus 2.2 plus j 1.5, and this value is equal to x of 412, which is given in the problem statement. So x of k1 is equal to x of 412. So thereby you can calculate the value of k1. That is, by comparing these two equations, 498 minus k1 is equal to 412, and by simplifying you can write what is k1. So k1 is equal to 498 minus 412, it is 86. So k1 is equal to 86. Similarly, you can calculate for k2 also. So what is x of k2 given? Minus 4.7 plus j 1.9, and if you take conjugate of this, it is equal to x of 309. So 498 minus k2 is equal to 309, and simplify and write what is k2. So k2 becomes 498 minus 309, which is 189. So k2 is equal to 189. So here I have done for k1 and k2. In the same way you can do it for k3 and k4 also. Try to get the solution for k3 and k4. Let us discuss in the next class. Okay. So this is about the symmetry property problems. So k3 and k4 you are going to calculate, right? So let me move on to the next property, circular convolution. The problem statement given is find the 4-point circular convolution of x of n 2, 1, 0, 0 and h of n 1, 2, 0, 0. So this is a problem which is related to circular convolution property. So what is the property statement is the circular convolution between two sequences x of n and h of n will take the formula y of n is equal to summation m is equal to 0 to n minus 1 x of m h of n minus m with circular shift n. So this is the statement we have derived, and we have proved the circular convolution property also. So using this expression I am going to calculate the circular convolution between the two sequences x of n and h of n. So let us substitute x of m as such from m is equal to 0 to n minus 1 in the form of a matrix, and for h of n minus m with circular shift 4 I am going to take it as, I will take the sequence first 1, 2, 0, 0. You can observe in the right hand side the h of n sequence is written as 1, 2, 0, 0, and I have made a mark which stands for n is equal to 0. Then I made the reflection, so it becomes 0, 0, 2, 1. Again the reflected sequence I just repeated, and I have taken the sequence only from 0 to n minus 1. So the value will be 1, 0, 0, 2. So this is taken as h of n minus m for n is equal to 0. That is the first row 1, 0, 0, 2 I have written. Again for the second row in the below matrix, you just take the last sample to the front for n is equal to 1, and for n is equal to 2 the last 2 sample to the front, and n is equal to 3 the last 3 sample to the front. So in this way we have framed the matrix form here, and this is multiplied with x of m, and just do the matrix multiplication. We will be getting as 2, 5, 2 and 0, right? So this is how to calculate the circular convolution between the given two sequences 2, 5, 2 and 0. So this is a very simple method to find the circular convolution using the matrix method. So this is another problem statement. you have a sequence x1 of n, another sequence x2 of n is given. You have to determine the sequence y of n so that y of k is equal to x1 of k into x2 of k, and x1 of k and x2 of k are 5-point DFTs of x1 and x2 of n respectively. So what you understood is, we have been given two sequences. You have to find y of n, whereas the hint is y of k is equal to x1 of k into x2 of k. So multiplication of the two DFTs will result in circular convolution in time domain. So we have a property, multiplication in frequency domain will result in convolution in time domain, that is circular convolution in time domain. So y of n can be written as circular convolution between x1 of n and x2 of n. So this just finding the circular convolution between these two sequences. So again, as I told in the previous problem, the first sequence you keep as such, the second sequence you just write it, reflect, and then again repeat it, and consider the sequence from 0 to n minus 1 so that the datas are 0, 0, 0, 0, 1. Again frame the matrix and do the matrix multiplication. So the first row is obtained as 0, 0, 0, 1. Again the second row is taking the last sample to the front. Again third row is last two sample to the front. Like that you have to do. Then do the matrix multiplication and you will be getting the circular convoluted output as 4, 0, 1, 2, 3. So this is the circular convoluted output between x1 of n and x2 of n. I hope it is very clear, right? So in today's class you have learned how to make use of the symmetry property and circular convolution property. Okay, thank you. Let us continue in the next class.